All right, time to do some derivations. So let's calculate the linear speed of the spool as it falls, and let's keep in mind, so free body diagram, we got tension, we got weight. So weight minus tension is going to make it accelerate. But then we also have torque. So we have the torque, the tension times the radius is going to be 1/2 mr squared times alpha, which is A over R. So, and I'm skipping steps. I kind of want you fluent at this point. We've done these quite a few times, and I know it's the end of the day and you're tired, but too bad, so sad. All right, so here we go. So starting with this whole idea here, we'll keep it simple and we'll get the acceleration. So keeping that in mind, there's going to be a lot of cancellation. But when we get it all canceled, t is going to be 1/2 ma. And so when we actually end up getting acceleration, it's going to end up being 2/3 g, just so you know. Now, for b, the angular velocity right before it strikes the floor, I like using conservation of energy. So I'll say mgh equals 1/2 mv squared plus 1/2 times 1/2 I, so 1/2 mr squared times omega squared, which is v squared over r squared. So we end up getting that mgh equals 3/4 mv squared. So when we actually isolate, we're going to end up getting 4/3 gh. All under a square root is v. And to get omega, we'll simply divide by r. So that'll be part B. And then the angular velocity of the spool as a function of time. Again, now friction is going to be applying a torque, so that's going to be mu mg times r is the torque. And it's a negative torque, which kind of wants to slow it down. So that's the torque due to friction, and that's equal to I times alpha. So now we can say negative mu mgr equals 1/2 mr squared times this alpha that we want to calculate. The m's cancel, and so we're going to end up getting alpha is 2 mu g over r. And for d, we want to know the horizontal speed of the spool as a function of time. Keep it real simple. Friction is m times a, that's mu mg equals ma. These cancel, and so the acceleration is going to be negative, well, it's going to be mu g. That's it. So if we want the speed as a function of time, it's going to be v equals mu g t. And then when does the slipping cease? Well, we want mu g. The mu g over r, okay, is what the acceleration should eventually equal to so that it rolls without slipping, equals negative 2 mu g over r times t plus the initial speed that we started at when we hit the floor, which is going to be negative 4 over 3 gh all over r. So this is the equation you use for E, and you use this to isolate T. So I want you to kind of look that one over carefully and work on it. I'm going to actually have us do this in class. So that's kind of a good little problem to continue with. I think that might be the, oh, I like this. This last one, I think we'll work on that one together too. So, yeah, it's good.